All right, let's solve this rational inequality. As soon as I see this less than sign, that tells me that this is going to be one of those problems where we're going to have a number line. And we're going to plot some critical values on here. And we're going to do some test values, you know what I mean? And we're going to get like yeses and nos. And those yeses and nos are going to tell me where the solutions are. So that's the overview of where we're headed. So this should be looking familiar. We've done this before with polynomials. All right, the only difference, there's only one difference between doing this with rational functions, with these fractions, and doing it with polynomials. The only difference is with polynomials, the way we would find the critical values that go on the number line is we would set up an equation. All right, I'd make it an equal sign instead. I'm still going to do that. But in addition to whatever solutions I get, those solutions will go on the number line. But we will also put excluded values on the number line. That's the only difference. Excluded values also go on the number line. So at a glance, somebody tell me, do I have to call a specific person? Tell me about the excluded value. What is it? X cannot equal 5. So x cannot equal 5. The number 5 is going to go on the number line in addition to whatever solution we get from solving this equation. That's the only difference. All right, everything else I do should seem familiar to you. So I'm going to solve this equation now to get the other excluded value or values. The way we solve these equations, you guys are really good at this. I'm going to make like denominators. So I'm going to put x minus 5 down here, and that's valid as long as I put the same thing in the numerator. Now that I have like denominators, I can cancel these denominators out and make a new equation that goes 2x minus 7 equals 3x minus 15. All right? Any questions so far? So I'm just going to keep going. I only see one type of x, just plain x, no x squared. So when I see that, that tells me I can get x by itself. So I'm going to get all the x's on the left, I'm going to get the numbers on the right, and get x by itself. So that means I'm going to subtract 3x from both sides. So that'll give me negative x minus 7 is equal to negative 15. And then I'll add 7 to both sides. All right. So that's going to give me negative x is equal to negative 8. Divide by negative 1. And that gives me x equals positive 8. So that's the other critical value that I'm going to put on the number line. So I'm just going to come back up here and put x equals 8. So these are the two values that are going to go on my number line. Okay, so here we go with the number line. Ta-da. So I have 5 and I have 8. Okay, listen carefully. If you might have spaced out for a second there, here comes a new element. We've got these excluded values that we didn't have before. Excluded values are always going to be open circles. I'm just going to say that one more time. Excluded values are always open circles. Now, if you think about it, that just makes sense because an open circle means, hey, don't include this value in the solution set. And of course, we don't want to ever include an excluded value, right? That just makes sense. So always open circles. On the other hand, the solution to the equation, this 8, sometimes it'll be an open circle, sometimes it'll be a closed circle. What do you think this time, guys? Is this one going to be open or closed? This time it's going to be closed. Why? Because of the less than or equal to. The or equal to part of the less than or equal to means include the 8 because the 8 is where the function is equal. Okay, so we want to include that. So now we'll just do our test values like you do. So over here to the left, maybe I'll pick 4. Between 5 and 8, maybe I'll pick 6. To the right of 8, maybe I'll pick 9. You don't have to use these exact same values as long as you have one in each zone. Christian, now you're on my video. Wake up. You don't want to be on my video, guys. Not for a bad reason. That's forever. That's on the internet now. Let's see. So now we have to test these. We got to test these. I would use, when it's real simple, we just plug them in by hand. But this is complicated enough that I would recommend using our TI-30 XS multiview. So here we go. So table function, clear out what's in there. I'm just putting in the left-hand side here. All right, 2x minus 7 over x minus 5. So fraction mode, 2x minus 7 over x minus 5. All right, make sure your calculator is in Ask X mode for this. Okay, the three values I wanted to check out are 4, 6, and 9. So I'm going to put 4, 6, and 9. All right? So I have negative 1, 5, and 11 fourths. All right, so negative 1, 5, and 11 fourths. Now, very often we have 0 on the other side of the inequality. This time we don't, so be careful. So the question is, are these values less than 3? We know they're not equal to because we already, that would be the 5 and the 8 is where they're equal. So are these values less than 3? That's the question. So I'm just going to write that next to all of these. Less than 3, less than 3, less than 3. That's what we're asking. So is negative 1 less than 3? Yes, surely it is. Is 5 less than 3? No. To be sure about 11 fourths, I would just go ahead and evaluate it real quick. I could have done it on the other screen. So that's 2.75. All right, is 2.75 less than 3? So we have a yes, no, yes. The yeses show us where the solutions are on the number line. So that means we have solutions over here, and we have solutions over here. And then, so we'll do our interval notation. So that first arrow goes from negative infinity to 5. Parenthesis or square bracket? Parenthesis, because it's an open circle. And yeah, parenthesis is singular for parentheses. That's why I'm saying that. So we will use a parenthesis to indicate the 5 is not included. So union, parenthesis or bracket on the 8. So bracket 8 to infinity. So this would be the interval notation. All right, that's it. That's how you do it.